Good morning, students. How are you all? I hope you all are doing good. So last time we discussed Thomson model of atom, and today our topic is Rutherford's alpha ray scattering experiment. I'm repeating, Rutherford's alpha ray scattering experiment. It is having one more name, that is Ziegler-Marsden experiment. Ziegler-Marsden experiment. Along with Rutherford, Marsden and Ziegler doing a lot of experiments to get more information about atom, because according to Thomson model of atom, we have already discussed limitations of that model. They want to discover new things, and by this experiment they discover nucleus. That's why its another name is discovery of nucleus. In 1909, Rutherford, Ziegler and Marsden performed a very well experiment which helps them to discover the nucleus. So, firstly I will tell you the requirement of this experiment. Diagram, I think it's clear to you. A is an element, a special element, radioactive element. I think you know something about radioactive substances and radioactivity. In the same unit, we are going to discuss radioactivity in detail. Radioactive elements are those elements which emit few radiations continuously, which emit few rays. Alpha decay, beta decay, gamma decay are examples. So, we need a radioactive element which will emit alpha rays. Alpha rays consists of alpha particles. Now, what is alpha particle? Alpha particle is very similar to helium nucleus. You know the atomic number of helium is 2. So, it is having 2 electrons, 2 protons and 2 neutrons. Helium, I am telling you about helium. Helium, its atomic number is 2. That means its number of electrons and number of protons are 2. But alpha particle is a positive charged particle. That means it is not having electrons. If we remove 2 electrons of the helium, then we get alpha particle. Alpha particle is having positive charge because it have only 2 protons and 2 neutrons. It doesn't have any electron. No electrons are there, only protons are there. That's why alpha particle is having positive charge. I think this thing is clear to you. We have taken a radioactive element which is emitting alpha rays, and they consist alpha particles. Alpha particles are positively charged particles. They have 2 protons and 2 neutrons. They doesn't have 2 electrons. Then fine slit collimator. You can see a barrier is there and a small opening is there. This small opening will help you, the coming beam, to adjust the width of coming beam. We use fine slit collimator. To adjust the width of coming beam, we use fine slit collimator, so that the alpha rays which are coming from the source, they can move in single direction. They are not going anywhere else. They can move in single straight line. This one is a radioactive element which is emitting alpha particles. Here we are using fine slit collimator. After that, this we are having a thin sheet of gold foil or thin sheet of gold metal. And the thickness of this gold foil is of the order 10 to the power minus 8 meter. That means foil is very thin. You know the quality of metals. They can be converted into thin sheets. That's why we are using here gold foil, whose thickness is 10 to the power minus 8 meter thick, thin gold foil. And here we are having zinc sulfide screen. Zinc sulfide screen is an example of photographic film. Now what is photographic film? Photographic film is used in these type of experiments. On these films we get spots. How we are going to form these films? We simply use a glass plate and coating of silver salts is to be done on those glass plates to make them photographic film. When any light is falling on those photographic film, spots will be there, and using those spots we conclude our results. Suppose we are not using this gold foil. Alpha rays are coming from there, they are moving straight. Nothing is there, no obstacle is there. That means this ray will go straight, and on photographic film we get a very bright spot of light. But when we put gold foil here, it will change its path also, and the spot we are getting, that is not so much bright as in the previous case. The reason is at that time nothing was there, and at this time we are using a gold foil. So this one is a general introduction of experimental setup only. Radioactive element, fine slit collimator, thin gold foil and zinc sulfide screen. It is a photographic film. I think experimental setup is clear to you. This whole setup was placed in vacuum. This whole setup was placed in vacuum so that alpha ray particles are not going to interact with air molecules. We placed this whole experimental setup in vacuum so that alpha particles are not going to scatter with air molecules. So, what we observe here, look at this diagram. We observe that first of all observation is there. We consider 3 points. The main point is many of the alpha rays will go straight without any deviation, because it is not a single ray, it is a combination of rays. And combination of rays, we are using word beam here. Beam means multiple alpha rays are going there. So most of the alpha rays goes straight. Few of them deviate with small angle. An angle we can draw like this. Here also we have drawn the angle. Most of the alpha rays goes straight. Few of them deviate with a little angle, and very few will deviate with greater than 90-degree angle, and one alpha particle out of 8,000, 9,000 alpha particles. If I am scattering 8,000-9,000 alpha particles, then out of them only one alpha particle will retrace its path. Students, these points are the observation of this experiment, and this will give us the detail of atom. I am repeating my points. Most of the alpha rays goes straight. Few of them deviate through small angles. Very few will deviate by more than 90-degree angle, and one particle out of 8,000 or 9,000 particles will retrace its path. These were the observations. And how do we get these observations? From photographic film. On that photographic film we get spots. If no gold foil was there, rays are going straight, we get that spots. Now we have spots in different directions. So using these observations, I am drawing a graph. On this x-axis, I am representing theta, that is scattering angle. By how much angle alpha particle is scattering. And on y-axis, we are having number of alpha particles scattered. Suppose we are having 10,000 alpha particles. Then from the graph it is very clear. These are the number of alpha particles. Maximum atoms will deviate through, here is the angle of theta, which is very small, and number of particles are very large. That means most of the alpha particles deviate through very small angle of the order of 1 degree only. After that, when theta is increasing on x-axis, if we are moving towards that, then theta is increasing, but simultaneously you can see number of alpha particles are decreasing. The same thing we have said here. It is only symbolical representation of our observations. This one is experimental setup. This diagram is representing the observations, and this one is the conclusion. Number of particles scattering, and here we are having scattering angle. So for small angles we have more number of particles, and for high angles we have very few number. This thing we have already discussed here. So according to these observations, it was considered that we are saying na, gold foil is here and rays are going straight. Most of rays are going straight. That means in an atom there is a hollow space. Because alpha, I am already discussed, it is having positive charge. A positive charge is moving and it is moving straight. That means no obstacle is there to disturb that ray. That means most of the part of atom is hollow inside. First main conclusion using this experiment's observation. Most of the part of atom is hollow. Reason is because alpha rays are going straight. Second point, which are deviating through small angle. Few are deviating through large angle and very few are deviating through 180 degree. If a positive charge is going and it is retracing its path, means jana tha straight and it is returning, taking U-turn. How is it possible? It is possible only when it is get repulsion from someone. And positive charge get repulsed by only positive charge. Positive ray is moving straight and it is retracing its path. What does it mean? That means something positive is there which is repelling it. And what is that positive? That was nucleus. That's why name of this experiment is also discovery of nucleus. It was observed that positive particles are retracing their paths. That means some positive thing is present inside the atom. We know spherical shape of the atom. Inside that spherical shape, some positive thing is there. And that positive thing get named as nucleus. That means it was clear. Atom almost part is hollow and inside the atom some positive charge is present. Now, we are saying almost rays go straight very few deviate through small angles and very few will deviate through large angles. That means size of that positive is very small. Size of that positive is very small. If that positive charge inside the atom is bigger, then almost alpha particles will scatter through large angles now. But the number of alpha particles which are scattering through large angle number is very less. That means size of that positive charge present inside the atom is very small. And it was given that up to the order 10 to the power minus 15 meter. Yesterday we discussed the radius of atom. What was that? 10 to the power minus 10 meter. Today I am saying the size of nucleus, which is 10 to the power minus 15 meter. Second thing, I am saying alpha particle. They are not lightweight particles. 2 protons and 2 neutrons are present there. That means they have some mass. And if a thing which is not light in mass, which is having some heavy mass, and it is retracing its path, that means their present thing, that positive thing which is present inside the atom, that is also having some mass. Because if suppose we are having a ball and we are having a ball, we are having a ball and we are hitting the ball, we get the ball back. Why? Because the ball is heavier than that. Suppose now you hang a hanky or a paper on 2 clips and then hit the paper with ball. Paper will also move. That will also change its position because paper is of lightweight. The same thing, when alpha particles are moving there and they are retracing its path, that means something which is present inside the atom that is also having mass. Are you getting my points? I am repeating. Almost alpha particles are going straight. That means most of the part of the atom inside, that is hollow. Few are deviating through small angle. If a positive charge is present here and positive ray is coming, so it gets a little repulsion. The next ray is coming which is nearer to this, it will scattered by more angle, and which is going straight towards the center of nucleus, that will retrace its path, that will scattered by 180 degree. That means a small size having some mass is present, having some mass and having positive charge is present inside the atom, and that thing was named as nucleus. That's why this experiment is very famous, because it gave the concept of nucleus. I have already sent you the notes of this topic. Please read those notes clearly, thoroughly, and listen the video again and again so that you can get clear. Okay students, for today it's sufficient. Tomorrow we will discuss distance of closest approach and Rutherford model of atom, because by performing this experiment he came to know about the new concept nucleus. So Rutherford gave one model of atom. So first was the Thomson model of atom and second will be the Rutherford model of atom. Thank you and have a nice day.